This video is covering how we write equations for parabolic paths and solve problems at NCEA Level 2. They have a question like this every couple of years, merit or excellence level. It's going to assume that you can do all the solving. We'll go through that quite quickly. We're going to focus on the process itself. The questions are very similar to the Level 1 tables, equations and graphs parabolas, except that the solutions tend not to be whole numbers. So let's revise that year 11 stuff. A parabola has an equation that can be written from the intercepts, and at the higher levels there's a component m which determines how steep it is. So I and j indicate where it cuts the x-axis, and m is how high or low it is. So we have a parabola like that. We have two intercepts, minus 2 and 4. We put those in as the negatives. Minus 2 is plus 2. And then we can calculate the m because we have a given point. It's 1 across minus 0.9 down. So if we substitute the x values into our equation and the y value into the equation at the matching point, we get that, which solves to give that, which tells us that m is 0.1. So the equation for our curve here is this: 0.1 the steepness, which we calculated from our given point, and the other 2 points from the intercepts. We can make life a little bit easier if we make one of the intercepts 0, because x minus 0 is x, and that just makes life a lot easier all the way through. So this is the process. We'll go through each step in an example, but basically we're going to do what we did before just then in our revision, and then do it in the context of a problem. So this is how we go. Let's take a path. We're told it's 6 meters wide, 2 meters high, and we want to know how long it is over 1.2 meters. So we stick it into a grid, and we make the far left hand point our origin, 0, 0. Then we rewrite it in that form where I is minus 6, because we were told that it was 6 meters wide. So from 0 to 6 is 6, and that gives us the I value. Then we substitute in a known value. We're told that it is 2 meters high, and because parabolas are symmetric, it must be halfway across, so it must be at 3. So in our equation, we substitute x is equal to 3, when y is equal to 2, and then we solve that equation to give the m value. So m is minus 2 over 9. The negative just means that it curves up that way rather than positive parabolas, which are more like a smiley face. So we stick minus 2 over 9 into our m value. We have our equation that describes the path of that parabola. The next step is to use that equation to solve the problem. We're asked how long is it over 1.2 meters high, so our y is 1.2. We multiply the 9 across, expand the brackets, rearrange and solve, and we get x values 1.1026, 4.8973, which represent on the graph the points at which it is above 1.2 meters high. And we answer in context, how long is it over 1.2? Well, it's the difference between those two numbers. We subtract them and we get 3.795 meters. And that's the answer to our question. So the process: set up a parabola so that the left hand point is the origin. You then just have to know that it's y equals mx, x minus I, where I is our intercept. Substitute in a known point, get the value of m, and then use that equation.